Hello everyone, welcome to part 12 of Econometrics, where I'm going to give some additional comments on the t-test and interpret results in different scenarios. Basically, I'm giving you a short summary of what we have done so far with a bit of additional comments here and there. Alright, so by now, I hope it's clear that we want three statistical properties or conditions for our main estimator, and they are unbiasedness, consistency, and sufficiently low condition of variance. If our OLS assumptions are satisfied, then unbiasedness and consistency are guaranteed. And in addition to assumptions being satisfied, if we also pass the t-test, then we can say that we have sufficiently low condition of variance of our main estimator. These three statistical conditions finally lead us to say that beta 1 hat is statistically reliable in representing beta 1, which is the causal effect of x on y. So if you remember, one of the main questions for us in the past videos was, how low do we want the condition of variance to be? We want condition of variance to be as low as possible because lower the condition of variance, the more likely that our estimate will be close to beta 1, the true causal effect. But again, the question is, how low do we want it to be? If you remember, I had said in one of the past videos that we want the condition of variance to be low enough to reject the null hypothesis in a t-test. What was our hypothesis? Well, if you remember, our hypothesis was that beta 1 equals 0. The technical name for this hypothesis is the null hypothesis. And this particular null hypothesis is the one that's most commonly used in t-test. We also learned in the past that the null hypothesis is rejected if we get an extreme value for the t-statistic, whether it's positive or negative. And if you look here at the bottom, the term in the denominator is square root of condition of variance of beta 1 hat, which means that in order to get an extreme value of t-stat and reject the null hypothesis, the condition of variance has to be sufficiently low relative to beta 1 hat in the numerator. And of course, saying that we want condition of variance low enough to reject the null hypothesis is the same as saying that we want condition of variance to be low enough to say that statistically, beta 1 is not 0. So putting everything all together now, if you are able to reject the null hypothesis, then we can say that we have sufficiently low condition of variance, and we can finally say that beta 1 hat is statistically reliable in representing beta 1, as long as unbiasedness and consistency are also ensured. Now, the next scenario we have to consider is, what if we cannot reject the null hypothesis? Well, then statistically, we also have to consider the possibility that beta 1 is 0. In other words, we cannot say that we have sufficiently low condition of variance, which means we also cannot say that beta 1 hat is statistically reliable in representing beta 1, the causal effect. As an example, our estimate of causal effect came out to be 0.048 using our sample with 30 observations. But if you cannot reject the null hypothesis, then like I said, we have to consider the possibility that the true causal effect is 0. In other words, it could be the case that the true causal effect is 0 or even negative, but you got 0.048 from your sample simply because of randomness. So in this case, are you going to be comfortable saying that the causal effect of x on y is 0.048? Who knows, maybe the causal effect is really close to 0.048. But in econometrics, if you cannot reject the null hypothesis, then you simply cannot rely on your estimate from your sample to say much about the relationship between y and x. Well, you can try to say something about it, but other people will probably not take it seriously. So I hope you remember in one of my past videos, I mentioned that the minimum threshold for statistical significance is 10% in econometrics. So if you do some kind of research and if you happen not to be able to reject the null hypothesis even at 10%, the minimum threshold, then people will not take your results seriously. Most likely your research is not going to get published in some kind of academic journal. Now, the next scenario we should consider is, what if we now have sufficiently low condition of variance, but we don't have unbiasedness and consistency? Well, in this case, beta 1 hat does not represent beta 1, the causal effect, but beta 1 hat is statistically reliable in representing something other than beta 1. So in this case, we can say there is a positive or negative association between y and x. Now, the last scenario I want to mention is, what if we now have consistency but the estimator is biased? Or What if we have unbiasedness, but we don't have consistency? Yes, it's possible for estimators to be unbiased and inconsistent, or biased and consistent. But in most situations that we actually care about, for the OLS estimator, if it's biased, then it's also inconsistent. For example, if there is omitted variable bias, then the estimator is going to be both biased and inconsistent. So in most situations, either you're going to have both problems together or none at all. And that's why at this stage, you shouldn't worry too much about the situations where the OLS estimator is unbiased and inconsistent or biased and consistent.